In this lesson, we're going to be solving equations again, but first we're going to simplify a side as much as we can before we go ahead and complete the solving. This is usually the easiest way to go. There are other ways to solve it, but this is the most standard way to go and usually the most straightforward way to go. So what we're going to do here is we're going to use the distributive property to sometimes remove parentheses by using the distributive property, and adding like terms is also an application of the distributive property. So in example 1 here, we want to simplify the left side first because we have some like terms that we can add together before we go forward with solving. Now again, we could solve it right from this, but it's going to be easier to add like terms first and then go ahead and solve from there. So looking at this one, I see that I have a 3x here and a 5x. Those are like terms, so I can add those. 3x plus 5x is 8x. And then we have a 2 and a negative 7. Those are like terms. Neither of them have variables, so 2 plus negative 7 is negative 5, and that's equal to 28. So in one step, we got it down to an equation that we're more familiar with. Here we want to solve for x, and we want to get rid of what's added or subtracted from the variable first, which is the 5. So we'll go ahead and add 5 to both sides. And when we add that, we get 8x is equal to 33. And then dividing both sides by 8, we get x is equal to 33/8, which I'm good with. If you want to change it to a mixed number, that's 4 1/8. So we simplified the left side first, and then went ahead and solved. Here's one that has parentheses in it. So now we want to use distributive property when necessary, simplify it, and then solve it after we've simplified the left side. So we want to make that left side look more tidy by simplifying it. So this 3 can be distributed to the x and to the 1, which gives us 3x plus 3. And now we have a negative outside this parenthesis, so the negative gets distributed to both of those, which means it changes both those signs. So what was a positive x before is now a minus x. What was a negative 2 before is now a positive 2. That's equal to 13. Now we're going to look at like terms again. So we have a 3x and a negative x. That gives us 2x. A positive 3 and a positive 2 is 5. So we have 2x plus 5 equals 13. Now again, we're to a simple one. We want to subtract the 5 first. So we'll subtract 5 from both sides. That gives us 2x is equal to 13 minus 5, which is 8. And we'll finish by dividing both sides by 2. And x is equal to 4. Now remember, you can always go back and check these. So let's see if we can fit a check in here up above this example 2 just to see. So we're going to have 3, and we found that x is equal to 4, so I'm going to put 4 in for x. So 4 plus 1 minus, open parentheses, we have 4 minus 2, and that should be equal to 13. So let's do our order of operations. We'll add what's inside here first. 4 plus 1 is 5, minus 4 minus 2 is 2, is equal to 13, and this is 15 minus 2, which indeed is equal to 13, so our x equals 4 is correct. So with solving equations, you can always see if you have the right answer by checking the solution by putting it back into the original equation. Here we have a word problem that we're going to work through. I listed the different steps. The first step we want to do, we want to read through the problem and assign a variable to the main unknown, and we'll talk about that in a minute here. John's mother is 4 times as old as John. John's brother is twice as old as John. If you find the sum of their ages and add 3, you get 80. What are the ages of all 3 people? So in this case, we have 3 unknowns. We want to know mom's age, John's age, and brother's age. But we don't want to use 3 different variables because we can't solve for 3 different variables with just one equation. So this says find or assign a variable to the main unknown. Now the way that I determine what the main unknown is I see what everything's being compared to. So as we read through this, John's mother is 4 times as old as John. It's comparing her age to John's age. John's brother is twice as old as John, again comparing to John's age. So John's age is our main unknown because the others are related to it. So we're going to go ahead and assign a variable to John's age. So we will let J equal John's age. So that was the first step. Second, we want to come up with some other word phrases and use the variable to represent those. So this first sentence or this first phrase, John's mother is 4 times as old as John. So if we want to find mom's age, we know that's 4 times the age of John. So we have already said John's age is J. We don't know it yet. That's an unknown. But we know mom's age is 4 times that. So 4 times J. And then what do we know about his brother's age? Well, his brother's age, it says he's twice as old as John. So twice means 2 times as much as John. So John's age is J. So if we multiply John's age by 2, that gives us his brother's age. So we wrote several expressions. We have 3 expressions. One's John's age, the other 2 are the other 2 in the problem, their age. Now we're going to write an equation. So we want to find some equality in here. If it says if you find the sum of their ages and add 3, you get 80. Well, that's an equation. If you add things together and then add 3, you get 80. That's an equation we can solve. So something's equal to 80. If you add the 3 ages, well, that's John's age plus, which is J, plus mom's age, which is 4J, plus brother's age, which is 2J, and then add 3, you get 80. And so now we have an equation that we can work with, and we can simplify this left side first. We have J plus 4J plus 2J, which is 7J plus 3 equals 80. And now we can solve that pretty easily. We're going to subtract 3 from both sides. I'm going to run out of room here at the bottom, so I'm going to move up a little bit. So when we subtract here, we would get 7J, and then 80 minus 3 is 77. Dividing both sides by 7, or just thinking through that, 7 times what is 77? We see that J is equal to 11. So J is equal to 11. We wrote an equation and solved an equation. Check our solution. Have I answered all the questions in the problem? Well, I have J equals 11. What does that mean? Well, going back to what we assigned, John's age is 11. What else do we want to find? We want to find everyone's age. It says, what are the ages of the 3 people? So we need to find mom's age. Well, mom's age is 4 times J. So John is 11. Mom is 4 times 11, which is 44. I know it's 4 times 11 because of 4 times John's age. And then bro is 2 times John's age, so that's 22. Now real quickly we can check this. If we add all these up and then add 3, we should get 80, just as the problem says. So 11 plus 44 is 55, plus 22 is 77, and then adding the 3 is 80. So those are the correct answers. So I found the ages of the 3 people. In this same lesson, we are supposed to figure out how to convert a repeating decimal to a fraction of 2 integers. So we learned earlier that a repeating decimal is a rational number. And by definition, a rational number should be able to be written as the quotient of two integers. But we never really looked at that or saw why. So here's what we're going to do. It said the example 4 says express 0.036 continuing as a quotient of integers. Now here are the steps for doing this. We're just going to work through this step by step. Step 1, write an equation in which x equals the repeating decimal. All right, so I'm going to write x is equal to 0.36 continuing. Use the multiplication property of equality to multiply both sides of this equation by 10 to a power, where n is the number of repeating digits. What this is saying here is you see how many digits are repeating, and then you write a power of 10. The powers of 10 are 10, 100, 1,000, 10,000, 100,000. The way that you determine if you want 10 or 100 or 1,000 is by looking at how many digits repeat. So in this case, 2 digits repeat. So we want to use 100 because 100 has 2 zeros. 2 zeros when 2 digits repeat. So we're going to multiply both sides by 100 and get a new equation is what we're actually going to do. So we're going to get 100x equals 100 times 0.36 continuing. Subtract the original equation from the new equation formed by multiplication. Well, what we're going to do here, I'm going to rewrite this second equation because when I multiply something by 100, we know that it moves the decimal over twice. So I'm going to say, well, this is 100x equals, moving the decimal over twice would be 36, but it keeps repeating, so 0.36 continuing. All right, so I put that in a simpler form, so that was still really part of step 2. Now I'm going to look at step 3, subtract the original equation from the new equation. This is my original, the first one. This is the original. And this is the new one. So it says subtract the original from the new. So we have to put the new one on top, 100x equals 0.36 continuing. And we're going to subtract the original from that. Now we haven't looked much into this yet, but we can do this. This is actually an application of the addition property of equality. We're really adding or subtracting the same thing from both sides. So we're going to go ahead and subtract these. Well, 100x minus x is 99x. What is nice here when we subtract this, 36.36 continuing minus 0.36 continuing, these are the same thing. So those decimals are lined up, that becomes 0, and we're just left with 36. And now we're going to go ahead and solve this equation, which all we have to do is divide both sides by 99. And we can reduce here because 9 goes into both of these. 9 goes into this, into 36 4 times, and 9 goes into 99 11 times. And so we get x equals 4/11. So earlier when we learned this and we were talking about different types of numbers, we're like, oh, well, if it's a repeating decimal, we know it's rational. The definition of rational was it can be written as a fraction or a quotient of integers, and now we showed that 4/11 is equal to that 0.36 continuing. We'll do one more example, same idea. So it says, remember we're going to start with the first step, write an equation in which x is equal to the repeating decimal. So I'm going to write x is equal to 1.36 continuing. So it's a little different, only the 6 is continuing. I'm going to go ahead and use the multiplication property of equality and multiply both sides by 10. I'm multiplying by 10 because there is one repeating decimal. So I multiply by 10 because it has 1 0. Multiplying by 10 would give 10x equals 10 times this. And I'm going to rewrite this. I'm going to multiply by 10. So this is 10x equals, the decimal moves over one place, so it's going to move over one place. We got 1.36. I said that wrong and wrote that wrong. It's 13, because I moved the decimal over. 13.6. I'm writing this twice for a reason. 13.66 continuing. I'm going to step 3 where I'm taking the new one, 13, the new one, which is 10x equals 13.66 continuing, and I'm going to subtract the original from that, so minus x. And when I subtract, I subtract both sides, so minus 1.36 continuing. On the left side, it's supposed to be a minus sign. 10x minus x is 9x equals, the reason I extended this and wrote 6 twice was because now I see that this 0.6 or this 6 continuing, those become 0 because they're the same thing after that decimal or after that place value. 6 minus 3 is 3. Here's our decimal. 13 minus 1 is 12. I know that I want this as a quotient of integers. Well, I'm going to go ahead and divide by 9. And when dividing by 9, I have 12.3 over 9, and this is not a quotient of integers. So this is another little thing that you might have to do sometimes. I want the top one to be an integer. It is not. Well, in order to move a decimal over, I have to multiply by 10. So if I multiply the top by 10, I can also multiply the bottom by 10. And we will get 123 over 90. If you know your divisibility rules, you know that 123 is divisible by 3 because 1 plus 2 plus 3 is 6, which is divisible by 3. So we're going to divide the top and bottom by 3 so we can reduce this. I'm running out of room again, but 3 goes into that 41 times, and 3 goes into this 30 times. And so x is 41/30ths, which means 1.36 continuing is equal to 41 over 30.